Okay, let's go ahead and consider question number 6. This is DSE 2021 question. Let's see what the question is saying. A right angled triangle. So we have a right angled triangle. Has two equal sides. So it tells us that these two sides are equal. It's an isosceles triangle also. Of 1 inch each. This is 1 inch. And this is also 1 inch. One of these sides drawn horizontally is divided into n plus 1 equal proportions. So, just see here. I'm dividing this equally. So, this one is divided into n plus 1 equal proportions. Which means this is 1 upon n plus 1. This is again the next 1 upon n plus 1 is like this. This divided into 1 upon n plus 1 equal proportions. So you can consider it like this. So supposedly it is of 1 inch and I say n is 4. So I divide it into 5 pieces. So each piece is what has this height length of 1 by 5. This width, sorry, of 1 by 5. This is 1 by 5, 1 by 5, 1 by 5, 1 by 5 like that. Okay. So this is what the question is saying. On each proportion after the first, a rectangle is formed with the height equal to vertical distance from left hand end portion of the hypotenuse of the triangle. So what are we doing? We're going ahead and we are formulating a rectangle over and above it. Something like this. This is the first rectangle. This is the second rectangle. Third rectangle. Fourth rectangle. Fifth rectangle. Sixth rectangle, like that. I have formulated various rectangles on it. Now it says find the sum of the rectangle areas. Now please see this. This rectangle that I have formulated, I have tried to cut it here, and then this is what is the length of the rectangle. So what is this length is what I want to understand. To understand that, just see that this is an isosceles triangle. So whatever is left here is exactly what will be left here. And what is left here? I know that this width was 1 upon n plus 1. So this will also be 1 upon n plus 1. Which means that this length will be 1 minus 1 upon n plus 1. Which will be n plus 1 minus 1 upon n plus 1. Which will be n upon n plus 1. So for the triangle 1, I have the length as n upon n plus 1 and the width as 1 upon n plus 1. This is the first rectangle, sorry. Now look at the second rectangle. For the second rectangle, how much am I leaving out? Do you see that if I take this here, I'm leaving out 2 proportions. And the remaining is its length. So for the second, if I just zoom this a bit, for the second rectangle, I am leaving 2 1 upon n plus 1 portions and leaving that. The remaining is my length. So this will be 2n, this will be 2, sorry, this will be n plus 1 minus 2 upon n plus 1. This will be n minus 1 upon n plus 1. This will be its length. And width is the same, 1 upon n plus 1. Then I will go to the third rectangle. For the third rectangle, if I have to find out what its length would be, if I take it here, I'm leaving 3 n plus 1 proportions. So for the third rectangle, its length will be 1 minus, I'm leaving 3 n plus 1 proportions. So it will be n plus 1 minus 3 upon n plus 1. This will be n minus 2 upon n plus 1. This will be its length. And what will be its breadth? Same, 1 upon n plus 1, and so on. So basically what will happen is that these rectangles that you would be formulating, the length of the width of the rectangles would be the same. The width would, all of them will have a width of 1 upon 1 plus n. But the breadth, or the length would keep changing. For the first one, the length would be n upon n plus 1. The second would be n minus 1 upon n plus 1. The third would be n minus 2 upon n plus 1. Next would be n minus 3 upon n plus 1, and so on. Now it says, find the sum of rectangle areas and its limiting value. So first of all, let me find the sum of the area. What is the area? Area is length into breadth. So it will be n upon n plus 1 whole square, n minus 1 upon n plus 1 whole square, n minus 2 upon n plus 1 whole square, n minus 3 upon n plus 1 whole square, and so on. So if I have to add it, it would be a series. So let's find the sum of all the areas. N upon n plus 1 whole square plus n minus 1 upon n plus 1 whole square, and so on. So, n minus 2 upon n plus 1 whole square. I can take n upon 1 plus n, 1 upon 1 plus n whole square common, and what will I get? I will get n plus n minus 1 plus n minus 2, and so on. But isn't this the sum of first n natural numbers? And we know that the sum of first n natural numbers is n plus 1 by 2 into 1 upon n plus 1 whole square. So this will get cancelled, and I will get n upon 2 n plus 1. So this would be the sum of my series, n upon 2 n plus 1. So if I have to check this, the answer would be this, n upon 2 n plus 1. It's not coming anywhere, first of all. So B is the correct answer. But let's find its limiting value also. So to find the limiting value, it's very simple. I will say let limit n tends to infinity, n upon 2 n plus 1, and I will divide numerator and denominator by n. So I will get 1 upon 2, 1 plus 1 by n, and now I will just approach this to n tends to infinity. So it will be 1 upon 2, 1 plus 1 by infinity. Anything by infinity is 0. It will be 1 by 2. So its limiting value will be 1 by 2. So the answer to this question is B. 1, you have to understand that this was an isosceles triangle. Within the isosceles triangle, I was formulating these various rectangles. The first important technique was to find out the length of the triangle. That was the most important, length of the rectangle, sorry. So I was forming these various rectangles. You have to form the length of the rectangle. And after formulating the length of the rectangle, then it was easy. You just do length into breadth, you get the area, you sum up the area, you get the answer, and then you find the limit. Right? Okay. So the answer is B.